Hello, good afternoon and welcome to 100% Optical Online and our penultimate webinar on today's CET programme, which is brought to you in partnership with the AOP. For those of you that are joining for the first session today, we've had 5 webinars that have come before this, and content is accessible on the platform, but there's no CET associated with that. Tomorrow we've got a programme of business content which you can access. And there's also the opportunity to interact with suppliers and book meetings, all via the same platform. So let's crack on with the next webinar. So I'm Ian Beasley, Head of Education for the AOP, and I'll be hosting the webinar. And then we've got Molly on hand to answer any technical questions. We'll just go through some housekeeping before we get started. So the presentation will run for about 45 to 50 minutes, and then we'll have the remainder of the hour reserved at the end for any questions. There's one interactive CET point associated with the webinar, and we will be uploading points in the next 10 working days. It's worth stressing that you need to attend for the duration of the session to be eligible for a CET point. And if you've got any questions, then you can submit those via the chat function, and we'll try and get through as many of those as we can within the time frame. So let's make a start. So I'm delighted to welcome Peter Black, who's Senior Lecturer and Course Lead for Ophthalmic Dispensing at the University of Central Lancashire. And Peter will provide an overview of the features and properties of various frame materials, including the latest sustainable, environmentally friendly options, and also we'll consider how frame fitting can impact upon lens performance. So Peter, over to you.
Thank you very much, Ian, and good afternoon, everybody. I hope you've had an enjoyable day so far. Hopefully you can read these, but I'm not going to dwell on them for too long, but that's our learning outcomes for this session. As Ian said, we're going to look at some frame materials and some frame fitting characteristics, and hopefully what makes a good fitting frame. There is no rocket science here. I think there won't be a great deal that's new to many of you, but hopefully you will be updated on some of these latest new materials, and it might make you think about some of the common problems that we have in dispensing, particularly if we supervise others who are not registered and perhaps don't follow through with some of the basics as we'd expect them to. So as Ian said, it's one interactive CET point. There's the learning outcomes in bigger print. And your feedback at the end of this session is appreciated when you accept your points from on the GOC website. Any comments that you put in are always looked at and acted upon, and it's very useful if you can reflect upon the training and give us some pointers on how it might be improved in future. This particular CET is intended to be part of a series of roadshow events, and we're grateful for Wolf Eyewear for sponsoring this session today. So let's think about frame materials then. There's quite a wide variety of materials, and those of you who are dispensing opticians probably learnt quite a number of obsolete materials going back, looking at things like cellulose nitrate and perspex, and different types of plastics and metals that perhaps don't really feature within our dispensing armory today. But we are seeing a resurgence of some materials. Optil is shown there, and we are seeing those kind of materials coming back in fashion with fashion brands such as Gucci and Marc Jacobs. And of course, cellulose acetate remains the mainstay of plastic frame materials when we're dispensing. So it's worth just considering the features of cellulose acetate and how we can tell it apart from the other plastic frame materials that we have in our armory. Quite often when we do a session related to this one and a discussion workshop, we would ask you to come up with ideas as to how different materials can be identified. We look at things like the manufacturing methods and how the frame is coloured, its overall appearance and design, and also the type of bridge and the joints and how they're attached to the front and to the sides. Whether the side has reinforcements, for example, and how long those reinforcements are is also a good clue as to the material that a frame is made from. So cellulose acetate is still the most popular material for frames. We have, in my career, gone through different fashions. We've had quite a long period of time where metal was most popular. We had a spell at the turn of the millennium when rimless was probably the most popular eyewear. But we now seem to be back where plastic is the most fashionable, and it's been that way now for quite some considerable years. And acetate remains the most popular material. And I think that's largely because it is, firstly, it's widely used by manufacturers, but also it has probably the ability to be coloured in the most interesting patterns. So acetate is usually manufactured where it's cut from slabs of material and manufactured by cutting and routing. So in the past, it was often handmade, although these days it's mainly made using robotic machinery. And you can see this particular frame that we've got here, the different layers of material. So a fairly recent innovation is the colours changing vertically through the frame, as we can see here. With other traditional designs, we might have seen the slab of acetate was built up in layers from the back towards the front. And where we wanted to change the colour, we would simply remove a layer of top colour to reveal what is below. So you can see that it's quite an involved process to manufacture these different layers of colour. But there are some cheaper frames that are available, which are injection molded. So cellulose acetate butyrate is the material there, and some of the cheaper frames are made in that way. Telltale signs of a cellulose acetate frame, in addition to these colouring processes, if, for example, it's a plain black frame, then it might be difficult to tell that it's an acetate frame, but you can tell from the joints, which are heat sunken. So you take the plastic front, the joint is heated and then pushed into the plastic. Whereas with other plastic materials, generally the joints are in the mold when the plastic is added to the mold, so that the plastic sort of surrounds the hinge and you can tell the difference in that way. Acetate frames also have reinforced sides. So we can just see here a couple of pictures of acetate. So the bottom right, we've got these different samples of colours that some of our frame importers and distributors might use when designing styles. You can see the left-hand picture is where, in this case, a pinned joint is being added to an acetate frame. And then the top right, you can see the routing process. So you can see that the front has had quite bulky nose pads added, and at the moment they're square, but the whole thing has been cut out of this slab. And therefore you can see that relative to the amount of material in the frame, there's a really quite a high degree of waste with cellulose acetate production compared to, for example, frames that are injection molded, where there is hardly any waste at all. So that adds obviously to the cost of cellulose acetate, in addition to the fact that it may well also be handmade. So some of our very highest quality premium brand frames are acetate and are made in this way. There's also some other plastic materials that are still fairly current, although cellulose propionate seems to be taking a back seat these days. It was once used almost exclusively by Stepper for their plastic frames, but they've since moved on to a material called TX5. propionate is similar in acetate in appearance, and often it's quite difficult to tell it apart. But one of the telltale signs is often the half joints to the front are screwed on, as opposed to being heat sunken. They can't be heat sunken. Exceptionally, they could be molded within the front, but as I say, normally they're screwed on, and that's a fairly telltale sign of a propionate frame. Carbon fiber has moved on a lot in recent years. This is a black frame, BLAC, no relation. And I saw these frames at 100% optical in, was it January 2020? Seems an awful long time ago, and they were exhibiting there. And you can see the really quite attractive pattern of the weave of the carbon fiber material within the front of the frame here. Certainly when I qualified, which is over 30 years ago, carbon fiber was, really quite boring. It's always an opaque color. You can't achieve clear colors with carbon fiber, but the frames, although they were very lightweight, didn't have a lot of design features. But in the last 10 years or so, we've seen a lot of carbon fiber used with this sort of nice woven pattern. I'm certainly aware that a lot of the mainstream premium brands use carbon fiber in the sides, even if they don't use them in the front. And lastly on this list of the other sort of fairly mainstream plastic materials at the moment is Optil. So this is a really old frame at the bottom, an old Christian Dior. And you can see the sides there. There's a small reinforcement, and then the side itself does not have any reinforcement. So again, it's fairly easy to tell. And of course, in most cases, it will also have the Optil brand stamped on it. So those of you who are trainee dispensing opticians and might be required to recognize one of these frames in an exam, usually the logo has been removed. So do pay attention to those other telltale features, such as the lack of a full length reinforcement in the side. It's really important that people understand how to adjust these frames, because they're very easy to break if you don't know what you're doing. So moving on to some more modern plastics, the polyamide or nylon-based plastic materials, of which there are many these days, most of them are based on a material called acrylamide, which you might also know as TR90, and this orange frame here is an example of one of those. So with acrylamide, you can see there that there's often, you can achieve some quite nice matte finishes, which aren't necessarily achievable with some of the other plastics, but it can also take a very highly polished finish as well. And acrylamide TR90 is also marketed as different names. So for example, Wolf used the trade name CX, and Stepper now use TX5, for example. And manufacturers have their own little code names for these products. I have to say that it is all getting a little bit confusing, and in my opinion, I mean, for example, Wolf have moved away from using the phrase CX and calling it TR90, so that actually we know what we're dealing with as opticians, and we know to take the appropriate course of action when we're adjusting or glazing the frame. One of the oldest polyamide material is the Silhouette SPX, Silhouette Polyamide X is all that stands for. And again, that's a common material that we see in practical examinations for Abdo and the College of Optometrists. And nylon, sometimes we see nylon frames that are actually a mixture of carbon fiber and nylon, and it's difficult to know what to call them. But pure nylon frames, again, it's just another type of polyamide. There are hundreds of different nylons available for different uses, from things like tights and stockings right through to cookware and spectacle frames. So there are different grades of nylon available, and that includes within the spectacle frame industry. And just researching for this, doing this particular session, I was surprised to read that the Oakley O-Matter material is in fact a nylon polyamide material as well. So it is used in some very high quality eyewear, and has obviously got those benefits of being very light in weight and durable. But there are difficulties potentially because it can't easily be adjusted. So now just moving through onto some of the newer polyamide plastic materials. And these are all nylon-based materials, and you will have seen a number of these, no doubt. There was certainly a few of them were exhibiting at 100% optical in January last year, and were attracting a very large amount of interest. That's C2C, that's a picture, I think, of their stand actually at the exhibition. There's other brands, Eco-Conscious from iSpace, and Coral Eyewear, which are distributed by Wolf in the UK. And we've certainly seen a very large amount of interest in these kind of products. So you can see the little graphic there is trying to illustrate that we're taking plastics from the ocean, obviously litter and waste and pollution from the ocean, converting it into the pellets, the plastic granules that injection molded plastics are made from, and out of which in the end comes frames. And environmental concerns are an important aspect now. If you've watched the Netflix film Sustainability, and there's a related film called Cowspiracy, Sustainability has been in the top 10 on Netflix for a couple of months, and it doesn't make very pleasant watching in many respects. But what you can see is that there is a lot of plastic in the ocean, and being able to collect it and reuse it, it has got to be a good thing. And these three sort of brands, Coral, C2C, and Eco-Conscious, all are using recycled fishing nets and also other ocean plastics in order to make the frames. So things like plastic bottles and plastic bottle caps can be used to make different plastics. There are, of course, other eco-friendly, sustainable brands of plastic as well, or non-metal materials. Neubau do a material called Natural PX, which I think is still available via Silhouette, although somebody was telling me Neubau have gone it alone recently. But the Natural PX material is very similar in its properties to the SPX, but rather than being petroleum derived, it's derived from the castor oil plant, and it utilizes both the oil from the plant and also the cellulose material. Bamboo is another product, and this is used in frame manufacture in two different ways. So bamboo can simply be compressed under pressure to make the equivalent of sort of engineered wood, which can be used to make frames, and particularly the sides on frames. But bamboo can also be used as the cellulose component when making plastics. So if you think back to cellulose acetate, then our acetate frames are made using acetic acid and plasticizers to act upon cellulose materials. And the cellulose is usually obtained from cotton, although it can be obtained from wood pulp. But the finest quality is obtained from cotton. And cotton in itself, when you start watching some of these Netflix films, you can see is a very demanding crop, and it in itself it requires a huge amount of water to be grown, and then the production of the cellulose acetate also requires a large amount of water. So there are questions alongside the waste as to the sustainability of the cellulose acetate material when it utilizes cotton. So a lot of manufacturers are moving now towards other sources, for more sustainable sources for the cellulose material that it's based on, and bamboo is one of those. Bamboo, as you probably know, grows really, really quickly, and it's a very productive plant even in its wild state. You know, it doesn't require huge amounts of fertilizer, so you know, it is deemed to be sustainable. And we've also seen something of an increase in wooden frames in recent years, probably in the last 20 years. And you know, there are issues with wooden frames, particularly, you know, they're not necessarily that flexible, so they need to be glazed. Like some carbon fiber frames, they need to be glazed like a metal frame with a rim closing block. And you know, the sides themselves are not adjustable. Interestingly, though, we are just starting to see now some new scanning technology using the sort of cameras that you found in iPhones after the iPhone 11 and in most up-to-date mobile phones these days. These having 2 or 3 cameras to take a 3D image can be used to scan the face. And I would fully expect in the next year or two technology to come on board where we're able to scan our patients' faces. Unfortunately, perhaps they'll be able to scan their own faces from the comfort of their own home, which won't be very good for business. But I hope that opticians will get on board with this sort of technology, and then we can order frames that are made to measure, in which case adjusting wood, bamboo, etc. won't be a problem. You know, if we can make it exactly right to fit, then having a frame that can't be adjusted and that stays where it's put is actually a real benefit. So just to take you through the materials from Coral and from the other manufacturers of these new sort of recycled plastics, they all use, I believe, a material called Eco-Nile. And you can find all of this information online, and I'm sure you'll recognize some of the pictures if you do have a look. So the Eco-Nile regeneration system, as they call it, is in 4 stages, and it starts obviously in the beginning with the rescuing of the waste. So they now pay fishermen to, instead of dumping their nets at sea, to bring them to recycling points, and also to collect any nets that they find floating in the ocean or on beaches, etc., to collect them, and you know, they can get a small amount of revenue for doing so, which gives them the incentive to help with the system. And it's not just fishing nets, but fishing nets. If you watch the sustainability, fishing nets and the other associated plastic things like floats, ropes, and so on account for about half of all the industrial plastic that finds its way into the oceans. So this plastic material is collected, and additionally we have some other plastics that they use, in particular nylon carpets and other industrial plastic. It's then sorted out and cleaned, and as much of the nylon is recovered as possible. And you often hear people say, and certainly when some of these brands came out in the first place, people were saying that, oh, perhaps their quality wasn't as good, and you know, it was faulty. But actually, this This technology and this material is now being used in a huge amount of products, from football shirts and swimming costumes, to carpets, as well as spectacle frames. So it is, in its recycling process, it's really purified to getting something close to that of the virgin sort of nylon made from petrochemicals first time round. As they say here, it's getting back to its original purity. In other words, it's exactly the same as the fossil-based nylon, the TR90, etc., that other frames might be made of. And you can see the scale of the factories here as well. This is big business, and therefore it's not just sustainable from the ecological point of view, it's sustainable for the long term from a business point of view as well. And you can see that once the material has been manufactured and it's then made into these small pellets, and these pellets are then used in the molding process. So it's the plastic is remade. So initially it's made into long sort of noodles, I think they call them, which are rolled up, and then those noodles are then chopped into those tiny little pellets that are used for injection molding. These plastics are also used to create the threads, the yarns, and polymers for the fashion and interior design industries as well. And the fourth step is to reimagine. So fashion brands and carpet producers are using the EcoNyle, this recycled nylon product, to create brand new products. And the beauty of this is this nylon can be recycled indefinitely, and it doesn't actually lose any of its quality, providing it's purified properly in the process. So the goal here is that the products that we sell that are made of this kind of material can also be reused. So when patients have finished with their frames, they can take them back to their opticians, and they can go back into the recycling process, back to step one of the regeneration system. And you can see here a few of the products made from EcoNyle. We've got our threads, our yarns, carpet, furniture, swimwear, and of course sunglasses. So Coral Eyewear were the first UK company to turn EcoNyle into a solid material rather than thread and cloths that are made were made from the material up until then. If you watch the sustainability film, you can see just how much waste there is coming from the fishing industry in a year. 600,000 tons of nets are thought to be abandoned in the oceans every year, and they last almost indefinitely, about 600 years for them to break down. The real problem with these products in the water is, firstly, that obviously they can carry on fishing, so to speak. So a large number of fish are caught by the nets and obviously drowned, and also large numbers of marine mammals and turtles and other animals are damaged in quite staggering numbers, actually. Although it says there that one abandoned net entangles 30 to 40 marine animals per year, you can see on some of these films just how problematic it is. So Coral Eyewear is supporting this circular economy. They expect their frames to be recycled, and in the process of supplying the eyewear to independent opticians, those independent practices become the network, if you like, the recycling point for these frames. And there's also a discount incentive, apparently, when patients choose to do that. And using EcoNyle also reduces the global warming impact of producing nylon by up to 90%. So not only is it helping to protect marine life and clean up the planet, it's also helping on the fight against climate change. And you can see there the website econile.com, which tells you the full story. So it's great having all these new plastics, but what are the features and benefits of them? What are the issues? And when we're comparing our plastics, one of the reasons acetate has stayed so popular is because it's a really, really good frame material. It's comfortable, it's got good thermal compatibility, and above all, it's really easy to glaze and adjust. So what are the issues though? There are downsides to each of the materials. So acetate isn't actually hypoallergenic. Depending on the plasticizer that's used, it's the least hypoallergenic of any of the plastic materials. It can be easily damaged with its solvent, acetone, although that is useful as a glue as well. And as we've already talked about, it's a wasteful manufacturing process. Other materials, cellulose propionate. I'm sure many of you have experienced what happens when you spray solution 30 or methylated spirits on it. I've certainly had frames explode into a few dozen pieces when I've cleaned them with the wrong product because I've not realized that the frame was propionate. Optil actually is a pretty decent material in terms of its durability, but because it needs a lot of heat, sometimes people forget about it, leave it on the heater, and if it gets too hot, it'll just be destroyed out of shape. Because the sides aren't reinforced, if it's not heated hot enough, then it's likely to break when you try and adjust it. And it's tricky to adjust in that, you've got to heat it hot, hold it in place, and then cool it while it sets. And that's why your frame heater has a cooling button, so you can turn the heat off and keep the cold air blowing. Silhouette SPX and its relation Natural PX are both cold glaze, as are Grilamid TR90. So as it says on this lens here, TR90 cold glaze only. It's said not to heat TR90, but in my experience, you can heat it, but it needs to be heated really hot. And it's something you need to practice on maybe a frame that's not the patient's own to get the hang of it. CX is a Grilamid material that, again, can't be used with meths or solution 30. And there is a similar product to solution 30 called Safe Clean, which does a similar job of cleaning, and it smells nice as well, but doesn't break these frames. And the Econile material, cold glaze again, but you can heat it to adjust it. It needs to be heated pretty hot and again held in place until it's cool in order for the adjustment to stay. Adjustment is the downside of some of these materials, and actually what's happening now, this is a design slide off one of the sort of eco material platforms, and what they've done here, they're using the Econile material in the front and in the butt end of the side, and then they're using acetate for the temple tip. And actually you can see this on some of the stepper frames as well, where it's a TX5, a polyamide type material in the main, but then the tips are actually made of a material that's more adjustable. So sustainability, just to conclude on these plastics, for every 10,000 tons of Econile raw material that's used in frames, carpets, clothes, etc., it saves 70,000 barrels of crude oil and avoids 65,000 tons of carbon dioxide equivalent. So I think that's a story that patients want to hear. So that's plastic materials. If anybody has any questions, don't forget there is the ability to ask questions via the chat, and hopefully we'll have time at the end to field a few of those. Now what I'd like to do is just move on to some metal materials. So most of the frames, I suppose, that most of us dispense are what we would call standard metal frames, such as Manel or nickel silver. But there's also a host of premium quality materials, different types of titanium, stainless steel, and aluminium. So the standard metal materials are usually made of nickel, copper, and other elements in various quantities. Manel, I think, is about 68% nickel. I don't think it contains any copper. Nickel silver is 18% nickel. It doesn't contain any silver. Its majority component is copper. Copper beryllium is mainly copper, and then has a small amount of beryllium, which is a very hard, light, white metal. And the idea with all of these is that they've got really good resistance to fatigue. You know, although nickel in itself can cause allergies, it does have that really good advantage that, you know, we can bend it backwards and forwards many times without it breaking. If you've ever tried doing that with an old-fashioned metal wire coat hanger, you'll know that most metals, or a paperclip, for example, you'll know that most metals fatigue very quickly and can be broken just by bending them backwards and forwards a few times. So it's important with spectacle frames for them to be fit for purpose, that we are able you know, to adjust them repeatedly without them suffering fatigue and breaking. Most of these standard metal materials are plated. Depending on the color you want, it will be with gold or chrome or chromium dioxide, for example, to get a black type of material, gunmetal, and so on. Allergy is a common problem. Apparently, about 10% of us are allergic to nickel. I know I certainly am. And it's split roughly 17% of women and about 3% of men. And apparently women are sensitized to nickel by jewelry, and perhaps less expensive jewelry, if we can put it like that. So thinking about titanium, it's really good to have a look at the international standards on titanium. And if somebody is using that word on a frame, then they need to make sure it complies with the standards. And what the standards say is that if you use the word titanium, then at least 70% by weight must be titanium. If you use the phrase pure titanium, then at least 90% by weight of the frame must be pure titanium. And this is often sold as Japanese titanium and is of the finest quality. And to use that phrase pure titanium, then it must contain no nickel. I have to say that in my time in practice, I have seen a frame labeled pure titanium that had nickel screws. And unfortunately for us, the lady who purchased it purely because she has a very serious nickel allergy. You can imagine when you're taking your glasses on and off, quite often you handle the area where the screw is, and she managed to get herself an anaphylactic reaction to it. Unfortunately for us as well, she was a scientist based in a large pharmaceutical company. So she had the wherewithal in the workplace to test her spectacles for nickel content and was able to prove to us that the screws were nickel and that she'd been missold. So, it is important that when frames are advertised as pure titanium, that they are actually, they do what they say on the tin. When people are buying, products to protect themselves from an allergic reaction, we've seen stuff in the news with food ingredients in pret-a-manger and so on. We need to be careful that we're using a reputable supplier and that we know that we're getting what we're paying for. So on allergies, then memory metal is not necessarily hypoallergenic. You need to talk to the specific manufacturers, but a lot of memory metals are actually a titanium nickel alloy and therefore won't be hypoallergenic. and beta titanium, which is often used in those hingeless, rimless designs, which is really, really flexible. So sometimes that's described as beta titanium, other times just as titanium, but it's not a pure titanium. It's alloyed with other metals in order to give it that elasticity and flexibility. Other premium quality materials, so stainless steel. Stainless steel can be used to make the very thinnest profile frames. You know, it is super strong. It's got good corrosion resistance, although it's not as good as titanium, but it is at a lower price point, so might be better value for a lot of patients. So titanium, just to recap, is 50% lighter than other metal materials. It's more elastic, it's stronger, it's corrosion proof, and it's hypoallergenic. Memory metal has the obvious benefit that it'll spring back into shape, and is particularly beneficial for children's spectacles, but it can be quite tricky to adjust, and it's also not hypoallergenic. And stainless steel, very strong, corrosion resistant, and if desired, can be made to a thinner profile than any other metal. And just lastly, aluminium seems to be making a bit of a comeback with some manufacturers, and that's largely because of new manufacturing techniques. So historically, we were always taught that an aluminium frame, you know, for example, the half joints would either be pinned on, or the whole thing would be milled from one piece of metal. And actually, in recent years, it's been possible to weld aluminium. So as the new robotic sort of welding techniques have become available, then we're finding that the material itself is now gaining popularity with some manufacturers. So that's plastic materials and metal materials. What I'd like to turn to now is what constitutes a well-fitting frame. And if you recognize this young lady, I've been peddling this picture at CET events now for about 6 years. This young lady was the face of Optifer in 2015. And well, it just really annoys me when people who should know better, you know, use promotional photographs where the frame doesn't fit. You know, it's not a great fit on the bridge, and the optical centers or the pupils are very high in the frame as well. So what do you look for in a well-fitting frame? Perhaps the most simple thing is that the frame patient's PD is equal to, or as closely equal to as possible, the frame PD or box center distance. Avoiding decentration is clearly going to minimize the thickness and the weight and the cosmetic and improve the cosmetic appearance. But with plus lenses, do remember to order a minimum size uncut rather than just ordering from a standard blank. And the eye should also sit roughly on the horizontal center line. Now, if you think about, if the lower limbus coincides with the horizontal center line, then the pupil center is going to be 5 or 6 millimeters above it. If you've got a typical pantoscopic angle of about 10 degrees, then the optical center being 5 or 6 mil below pupil center is going to be in exactly the right place for the center of rotation condition to be satisfied. So the rule is, for every 2 degrees of tilt, we drop the centers by 1 millimeter from pupil center. And we should be doing that all the time. It happens that, if we frame style and keep the eye sitting on HCL, then we're probably going to get it right all the time. But we should be thinking about it and actually measuring it more often. This is just to show you the difference between on your right, the patient's left. We've got a large frame, a 5618, which would have a box center distance of 74 millimeters. And in the right eye, we've got a 4515, so a box center distance 14 millimeters less at 60 mil. And you can see the difference it makes. It's absolutely stunning. And, we've all seen colleagues, extolling the virtues of mid-index and high-index materials. And then the patient, when they get them, is disappointed because actually maybe they had a smaller frame last time, and it can make a tremendous amount of difference. And if the patient chooses a bigger frame and has mid-index lenses in them, then they may not save anything. But just to reiterate, we do need to remember to order a minimum size uncut. I know when I've picked my kids up from school, I can't tell you how many times I've seen children, we were +4, +6, and clearly they've been given stock lenses in their frames, because you can see the edge thickness in a plus lens all the way around, which we just shouldn't be doing. I do think it's shocking dispensing. So, no rocket science here, but it's worth remembering. And then obviously we use the same thing to calculate the blank size. Minimum size uncut, effective diameter, plus twice the decentration, plus a couple of millimeters for wastage. And this is just to show you, as I'm sure you're all aware, what difference it makes if you can center a lens properly at the box center. In other words, choose a frame where the box center is in the appropriate position, versus this particular dispense where the pupil center is really high in the frame. So not only is our uncut going to be very thick, we're also going to be cutting away the top of the lens if we center the lens correctly vertically. And you can see that, probably the patient isn't going to be too pleased with that extra edge thickness at the top. So basic rules on frame styling. The frame should always sit as close as possible without touching the lashes. And people think, they don't need to worry about vertex distance unless it's a high power. But even on low powers, fitting the frames close makes it, increases the field of view. It maximizes it. And with basic varifocal designs, the intermediate vision or the intermediate area might only be 4 or 5 millimeters wide. And, by keeping that as close to the eye as possible, it really is going to maximize the field of view through the intermediate and the reading portion with varifocals. We already covered for single vision, then, well, in fact, for most dispenses, the optimum pantoscopic angle is 10 degrees. For progressives, the rule is to fit on pupil center, and the manufacturer compensates for the pantoscopic angle. For single vision, as I've said, we need to lower the optical center 1 mil down from pupil for every 2 degrees of tilt. So I want to move on to now is when you're helping the patient choose the frame, what information do you give them? The GOC is really clear that we need to gain valid consent, and that for that consent to be valid, the patient must be appropriately informed. And we often think of consent as applying to things like surgery and, procedures such as applanation tonometry, but it also applies to the sale and supply of optical appliances. And the GOC has a view on something it calls forced selling. And this isn't just pushing people into products they don't need or are inappropriate, such as high index lenses for a -1. The GOC's view is we must give informed choice and offer the best product to everyone as part of a range for them to choose from. And we should never prejudge our patient. And it found against a practitioner local to where I live who had been seeing a patient who, unfortunately for him, was a medical negligence lawyer, and had offered the patient or dispensed the patient with standard disposable contact lenses, but never offered the patient an upgrade. Then one day when there was a locum there, the patient was offered an upgrade and said to the locum, well, how long have these lenses been available for? And was told they've been around for over 10 years. And that practitioner was sanctioned as a result of not trying to upgrade the patient. So, this isn't just about sales. This is about valid consent and informed choice for the patient. It's our job to tell people of the latest developments, and it's their job to decide whether they want them or not. So if you've got somebody who's getting glasses for the first time, what information do you give them? And it's very easy, isn't it, to think, well, the latest fashion is to go for a Ray-Ban Wayfarer type frame or whatever is in fashion at the time. But I still believe with a patient who is new to spectacles, who doesn't know the difference between a fixed bridge and an adjustable bridge, for example, that we should still go through and explain to the patients the difference between the different categories of frames that we have. The difference between plastic and metal, and then also we shouldn't forget supra and rimless. There is still a cohort of people who like the high quality hypoallergenic materials that you get in rimless spectacles, and also don't forget that rimless is really good from a customization and problem solving point of view. And we also need to talk about other issues and ask questions in relation to allergies, the patient's fashion preferences, and, as was said before, environmental awareness. So customers, in terms of valid consent, have a new sort of interest in knowing about the ethical principles behind the products they buy. They might expect, for example, to know if a product was tested on animals, which some of the contact lenses we sell are. Sustainability and environmental concerns. So they want to feel good about the products they buy, or they may want to feel good about the products they buy. And there's actually a Feel Good brand website, and Coral Eyewear was named on it just a couple of months ago. So that may be one aspect of consent that patients are interested in. So just to conclude then, and to thank Wolf for their support for this session, when dispensing patients, we need to ask questions to establish the patient's needs and wants. Our frame choice is dependent upon the patient's prescription, of course, their PD versus the frame PD, whether they have allergies, and their requirements for comfort, fashion, and cosmetic considerations. We should always identify the best frame stroke lens for the job and offer it to the patient along with a limited range of alternatives. And don't forget that environmental concerns are a top consideration for many people. Thank you very much. And are there any questions?
Thank you, Peter. Yeah, we've got quite a few questions that have come in. First one relates to 3D printing of frames. Do you think this is a concept that is taking off, and is it sustainable?
It is definitely taking off. I know some of the Neubau frames are 3D printed, and one of the issues I think with it is it's really good for matte finish frames, but they struggle currently with to get the same sort of gloss finish that you get on cellulose acetate. It's in terms of waste, for example, 3D printing isn't as good as injection molding, I don't think. And that's partly because they often have to sort of print a scaffolding in order to support the frame, because frames are curved. And they often have to print this sort of scaffolding in order to get the frame shape correct. And therefore, the scaffolding then has to be recycled later. I think it's definitely sustainable as long as the waste can be recycled back into the process.
Yeah, good point. Is there a regeneration system in place in the UK where we can send old specs other than sending them to the third world?
Well, the third world doesn't want them anymore, is my understanding. Certainly Vision Aid overseas have stopped collecting spectacles, and actually they were melting them down and recycling them for the metal anyway before they stopped. So products such as Coral, then they can be recycled through the stockist, is my understanding.
Okay.
So you need to check with your Wolf rep, and if you're dealing with any other companies with these kind of brands, then check with the supplier.
Next question is about bamboo. So do you know of any frame manufacturers that are using bamboo as a base for their acetate?
Not off the top of my head. It's a bit of a shame, really, because in 100% Optical last year in January, then there's quite a few of these sort of innovative niche sort of manufacturers there, and hopefully we'll be back in business, next year, and we can talk to the people. I mean, 100%, I have to say, is really good at sort of attracting those niche manufacturers. But yeah, you'll have to maybe, I don't know if we've got an ability to feedback later. I could certainly try and find out.
Sure, I'll give people a point of contact for that if they want to ask any further questions.
Okay.
And just on the point of 100% optical, we are aiming to return January 22nd to 24th next year, which incidentally coincides nicely with the GOC's new CPD scheme that they'll be starting. So it'll be great to see everyone there earning their new CPD.
Yeah,
face-to-face environment.
it certainly will.
What solution is best for cleaning cold glaze frames?
Oh, well, I use one called Safe Clean, which I think has come from Mainline Optical. So they're the people who do the Solution 30, and obviously they developed this water-based product as an alternative. So yeah, or just soap and water. You know, is pretty good as well. I think I mean most of the proprietary sort of cleaning products are okay, but you know, you just need to check and be careful with it. Check with the manufacturer.
Okie dokie. Question about acrylic. Any thoughts on acrylic as a frame material, which I think Kirk and Kirk use?
Well, it takes a really nice shine. It is a great material. I'm not overly familiar with Kirk and Kirk. I mean, historically, it was only ever available in Supras because it was difficult to glaze. And maybe somebody can correct me, but as I understand it, springing in is still a difficulty. So hopefully they've cracked that in some way and are doing it. But yeah, I'm obviously a little out of touch with acrylic, but it's certainly, you know, it's very, very highly durable. When I look at some of my teaching materials, I've got acrylic frames that are 50 years old that look as good as new, and you know, nitrate frames of a similar age that have just almost disintegrated into powder by now. So yeah, it's certainly very long lasting and good looking.
And just thinking about certain prescriptions and some of the plant-based materials, are there any restrictions on what you wouldn't recommend putting into, say, a bamboo frame? Thinking of the high pluses and so on.
If it's bamboo wood type material, then you know you've really got to go with the glazing house and see what they think they can do. My understanding is that a lot of these bamboo wood type materials have rim blocks like a metal frame. So the limitations from that point of view are probably similar to the metal.
Okay. And do you know if any of these sustainable materials are being developed in the UK, or at least relatively locally, or are they shipped from destinations far away, which negates some of the environmental benefits?
Good point. I mean, Coral is a UK company, and you know, certainly I think a lot of these products are designed in the UK. However, I suspect most of them are made in China. But maybe check with your supplier.
Okay, next question, Peter, is one relating to nickel. How do we recognise if joints are nickel on a different frame material?
Good question. I say the example I had, unfortunately for us, the lady was a scientist and she was able to identify it herself. But obviously, you know, there are manufacturers out there who make frames out of titanium, and there are no screws, and you can guarantee then that those joints are not nickel. You know, people like Lindbergh Silhouette, and there's a whole host of manufacturers now who are making frames out of titanium or a combination of plastic and titanium where there is no screw and no soldered joint. I suppose you can, if the joint is soldered, then it's probably nickel based. But if it's an integral, part of the hinge, and it's, you know, when I look at, I mean, I've got a pair of silhouettes here, and they're you know, they're just kind of clipped in, and you know, there's no soldered part. The side is all one piece, and the, you know, you've got the lug that going onto the lens or onto the front, and again, it's just titanium. So yeah, you've just, I mean, it's tricky, isn't it? I mean, I think if a frame is billed as being pure titanium, then I would be very confident that the half joints are titanium as well. But this one we had, it was the actual screw that was nickel. And the way screws are made, the way they're sort of cut, it's very difficult to make a screw out of titanium because it's such a hard material. So looking for titanium frames that don't have screws is probably the best way to guarantee there's no nickel.
Yeah, fair comment. I think, Peter, we'll probably just end on a comment rather than a question, which is Oliver saying, really great lecture, going to rewatch myself and get our student Dio to watch this too. So,
excellent.
So thank you, Oliver, for that comment. So if anyone's got any further questions about this webinar, then you can email events@aop.org.uk, and we hope that you can join us for our final CT session, which will start at 5:15, which is dry eye in the digital age. So thank you once again, Peter.
Thank you very much, and enjoy some sustainable dispensing, everyone.
Thank you.
Thanks a lot.